So when we study the term remote sensing and how remote sensing will be work, we know that to function the remote sensing whole the process, we have 7 elements, and these are the elements are energy source or illumination, radiation and the atmosphere. Secondly, and the third one, interaction with the target. So today's main topic is basically depend on these two things, radiation and the atmosphere, and third, interaction with the target. Okay, these two stages will be discussed in details in today's class. And the fourth one is recording of energy by the sensor, transmission, reception and processing of the energy, and interpretation, analysis, and the final stage was application. We already discussed in details, very much details in the previous classes. So these are the things. So in remote sensing, we know we must have an energy source. Without an energy source, we can't do remote sensing. And if you look at this picture, the energy coming from the sun, and it's interact with the atmosphere and then go to the earth surface, and again it's again interact with the atmosphere and then go to the sensor, recording instrument or sensor. Okay, so in its so energy in its journey interacts with the atmosphere twice. Okay. So we know in energy that is coming from the sun in the form of electromagnetic radiation, and it's basically consists of two fields. One is electrical field and second one is magnetic field, and both these fields travel at the speed of light. Okay, these are the previous slides we will cover, and in today's class is all about energy interaction of EMR with atmosphere and earth surface. So before that, we all know when we study EMR, basically two characteristics of EMR is very much important, and that is what? That is what?
So can you please repeat the question?
When you talking about electromagnetic radiation, there are two characteristics of EMR which important in remote sensing, and which characteristics are there?
Wavelength and frequency.
Yes, very good. Wavelength and frequency. Okay. So what is wavelength? Wavelength basically the distance between two crust. Basically the distance between two crust. And what is the frequency? Frequency is the, anyone? What is frequency?
Number of time waves passes in a second.
Yes, number of wavelength passes in a particular point in a particular time. That is called frequency. And wavelength is represented by the Greek letter
Lambda.
Lambda. Very good. And frequency?
Hertz.
Frequency in hertz.
Nu.
Frequency in hertz it's a measure. Okay. Just like we measure the wavelength in meters, we measure frequency in hertz. Okay. So these are the things we already previously done. So now today's topics, energy interaction or interaction of EMR with atmosphere, and then we will go to the earth surface features. So electromagnetic radiation or energy interacts with the atmosphere with the earth surface. So we know energy when coming from the sun, it interacts with the atmosphere. That is true or not?
Yes, sir.
Yes, true.
So how many times it will interact with the atmosphere?
Two times.
Two times. So the energy which interact with the atmosphere two times, so it is play a vital role in remote sensing. Why? Because in remote sensing we use, if you remember this picture, in remote sensing which energy we can use? We use reflected energy. That means that energy coming from the sun in the form of electromagnetic radiation at first interact with the atmosphere, then go to the earth surface, then again it's interact with the atmosphere, this reflected energy will recorded by the sensor. That is why this energy which interact with the atmosphere in twice in time very much important. Okay, so that is why it's called it's play a vital role in remote sensing. So in energy interaction with the atmosphere dictate the spectral region through which only we can do the remote sensing, which are known as spectral windows. So here I mention a term that is spectral window. So what is spectral window? Spectral window is basically the portion of the electromagnetic spectrum where energy when coming from the sun in the form of electromagnetic radiation, it's interact with the atmosphere, and there are some of the energy that will not coming, okay, that will reflect from the atmosphere, and some of the energy is coming in the earth surface. Okay, and these do the remote sensing, which are known as spectral windows. Okay, so energy interaction with the atmosphere dictate the spectral region through which only we can do the remote sensing, means which only energy passes in the electromagnetic spectrum where the energy passes without any obstacle. That portion of the electromagnetic spectrum is called spectral windows, and this energy will be used in remote sensing. Okay, so atmospheric.
Excuse me, sir.
Okay.
Excuse me, sir.
Yes.
Sir, atmospheric windows and spectral windows में difference होता है?
Atmospheric windows
and spectral windows?
No.
Or they are the same thing?
Same things.
Okay, sir.
So now going to the energy interaction with the atmosphere. Irrespective of its source, all radiation detected by remote sensor passes through some distance or path length of atmosphere. The path length involved can vary widely. So irrespective of its source. So actually I did not tell these things in the previous classes, will not cover. That is, in remote sensing there are two types of remote sensing, that is active remote sensing and passive remote sensing. In passive remote sensing we use naturally available energy that is coming from sun, and in active remote sensing we use artificial energy just like radar, lidar, that kinds of. Okay, so irrespective of its source, is it clear to everyone? That means it is active or passive. Okay, so all radiation detected by remote sensor passes through some distance. So we know in remote sensing which energy will be recorded by the sensor, that is coming from through a certain distance or through some distance or path length of atmosphere. Okay, so the path length involved can vary widely. So here I mentioned that the path length involved can vary widely because the reason behind this, in remote sensing basically the sensor in three types. Okay, ground based on the basis of platform. Number one is ground based platform, second one is airborne platform, and third one is space borne platform. So at the beginning of the class I told when we told that remote sensing, what is remote sensing? Basically most of the people think that is satellite remote sensing, but we can use remote sensing in airborne platform and through ground based platform also. Okay, so that is why I mentioned the path length involved can vary widely. Okay, if the sensor is ground based, then the duration of the energy cover, it will be very less. Okay, and if the sensor is located in the or installed in the any satellite sensor, that will cover most of the distance, is not it? Clear everyone? Is it clear? This line is clear to everyone or not?
नो सर.
ओके, मैं हिंदी में बोल देता हूँ. ठीक है, बेसिकली क्या है, रिमोट सेंसिंग में हम तीन तरह के रिमोट सेंसर यूज कर सकते हैं ऑन द बेसिस ऑफ प्लेटफॉर्म. एक क्या है ग्राउंड बेस्ड प्लेटफॉर्म, नंबर 2 है क्या एयरबोर्न प्लेटफॉर्म, और थर्ड नंबर है वो है एयरबोर्न प्लेटफॉर्म। सो अगर कोई सेंसर एयरबोर्न होगा या मतलब अगर कोई सेंसर कोई एयरक्राफ्ट में इंस्टॉल होगा तो उसको जो डिस्टेंस कवर करना होगा वो कितना होगा, वो सन से आएगा एटमॉस्फेयर कवर करेगा, उसके बाद वो क्या करेगा अर्थ सरफेस से इंटरेक्ट करेगा, उसके बाद जब वो एयरक्राफ्ट तक जाएगा तो वो जो डिस्टेंस है वो डिस्टेंस बहुत ही कम होगा। लेकिन अगर वो अर्थ सरफेस से इंटरेक्ट करने के बाद अगर वो सैटेलाइट तक जाता है तो उसको जो डिस्टेंस कवर करना होगा वो बहुत सारा डिस्टेंस कवर करना होगा। सो इससे क्या होता है, इससे जो एनर्जी है वो उसका लॉस होने का खतरा होता है। ठीक है, समझ में आया?
Yes, sir.
So that is why the path length involved can vary widely. So depends on path, it can vary widely. So because of the varied nature of atmospheric effect, so all of you know varied nature of atmospheric effect. If the sensor is ground based, the atmospheric effects will be less. If the sensor in a satellite, then the atmospheric effect will very much. Okay, so we treat this subject on a sensor by sensor. So this is why we treat this subject sensor by sensor, means it will be ground based sensor, it will be airborne sensor, or it can be satellite based sensor. So for example, space photography result from sunlight that passes through the full thickness of the Earth's atmosphere twice. As I told before, the space photography result from sunlight that passes through the full thickness of the Earth's atmosphere twice. Is not it? Look at this picture. EMR coming from sun, interact with the atmosphere, one time, then interact with the earth surface, again when it reflects the energy, again it interact with the atmosphere and then go to the sensor. So in its journey, this phenomena or the second stage radiation of the atmosphere, this phenomena will be occurred in 2 times. The full thickness of the earth atmosphere twice on its journey from source to sensor. So source is basically the sun for considering, okay, or in artificial energy sources like radar or lidar. So its source to sensor is full thickness of the earth atmosphere covered 2 times. On the other hand, an airborne thermal sensor detects energy emitted directly from objects on the earth. So a single relatively short atmospheric path length is involved. Clear? This line is clear to everyone?
Yes, sir.
Okay.